G'day and welcome back to RC Model Reviews. Have on the bench today the FrSky Horus X12S, it says here along the bottom, and it is a high-end radio from FrSky. And as you see, it's got lots of shiny bits. I think you get it in darker colour there. It's got little buttons and twirly roundies, and it's got a colour LCD screen, which is actually a pretty good damn colour LCD screen. It's got some nice switches, all these 3-position switches. You can never have too many of those. It's got sliders, so you can do a bit of DJ mixing while you're flying, you know, and all that sort of stuff. You can be Mr. DJ. It has 3 knobs, woohoo! And these 2 are potentiometers with a nice detent in the center position. This is a multi-position switch, so that'll be kind of cool for, what is it, how many has it got? 1, 2, 3, 4, 5, 6 position switch. No rotary encoders, but hey, that's cool. We've got little clicky buttons, sticks. Now these are Hall effect sticks, and of course you can now get Hall effect sticks for the Tyrannus as well if you want to upgrade. That's really kind of it on the back. We've got a bay where you can put a module, which is something that's a bit rare these days with modern radios. Most of the manufacturers have gone proprietary and say, we don't want you plugging anything into the back of our radio, so they've just got a plastic wall there. The Horus lets you plug in a module, so you can use the excellent FrSky 2.4 gig system with all your really important models, and you can plug in a Spectrum Orange module or whatever you want there, just for your bind and flies that you get from the likes of the local hobby shop. There's also little doors here which cover up things like USB, SD cards and other stuff. And there's also like buddy box connections and things. All sorts of things there. Direct servo connect and blah, 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 blah. Everything you could want, right? Okay, wonderful. Fantastic. There is an external antenna connection up here, as you can see, for putting and it's an RPSMA, surprisingly, not an SMA, RPSMA, for putting your favourite antenna on here if you want to use something different. And to be honest, when we have a look inside, I'll tell you, I would recommend using the external antenna for reasons which I will go into shortly. Under this little cover here, there is a GPS receiver. And I find that kind of odd where they've positioned that, as you'll see later, because with the transmitter in this position, that receiver is being blocked by the LCD, because the LCD has a metal shield over the back of it. So your GPS receiver is actually going to be not only very close to some noisy circuitry, but also effectively blocked, if you hold your transmitter like this, by the LCD. Strange choice, mind you. Where else could they have put it, I suppose? Due to the design of the transmitter, the physical design, the options are very limited in that respect. Now, we've got some sliders on the back here. Worst feature of the radio, perhaps one of the worst features. These sliders, look, you've only got this much here. See, from there to there. It's like 15 degrees, maybe 20 degrees of movement, and 20 degrees that way. There's a nice detent in the middle, but that's just not fine enough to allow us to be used for things like flaps or whatever. It's just not fine enough. And of course, I find that I can't reach that with my thumbs on the sticks. I'm a thumber, so if I'm flying with my thumbs like that, these are just out of reach with my average-sized hands. Big fail on that one. I really like sliders, I use them a lot, and these ones, can't use them. If you have it on a tray, if you're one of the people who have it on a tray, then you can still get at them, because this handle here on the back means the radio is not sitting dead flat, it's actually sitting at a bit of an inclination, as you could see if we were to draw an imaginary line. So you can use them when it's a tray radio, but why would you? Because these are more accessible. So, I don't know what they were thinking there. Power switch is under this little cover here. It's a little pop-up cover. Try and get you a side view of that, so you can see this pops up. And it's a soft power switch, so you have to hold that down for a fair amount of time to make it go, and then the same when you turn it off and then confirm, blah, blah, blah. The neck strap goes through this piece here. I'm not so sure I'm happy about that, because look, this is a little bit wibbly-wobbly. It doesn't give me the confidence that it's going to be robust and rigid, and if I accidentally drop the transmitter and it catches on the neck strap, it's not going to rip out of there, so don't know, it could have been a better choice for that. So we have a number of different switches here. You can see these toot, 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 and it's got a twirly roundy bit in the middle, and you can push that as well. Over here we've got a button like a joystick, a jog shuttle. If you remember the old IBM laptops, I've got one where you could use this instead of a mouse. This is also there, and it's got page up, page down. So there's a lot of interface stuff here. I tend to wonder if there's not a little too much, because there's so many things to push and whatever. Now there's some little vents here, and this is, I think, where the speakers come out. Tiny little vents, and despite that, it's really loud. In fact, I won't talk too much about the software, because software is a work in progress. This has got the original software in it. I wouldn't use the original software for reasons I'll explain later, but OpenTX. OpenTX is what you want to put in here if you're going to get yourself a Horus. I'm pretty sure most people would want OpenTX. It's just so much better. In fact, I don't know why FrSky bothered writing their own software. Maybe to make it simple, because there is a big learning curve with OpenTX. If you've never used it before, it can be quite daunting the first time you get out there. But the functionality provided by OpenTX is just so good that it's worth learning. It's worth putting in the time to understand how it works, because with increasing number of radios coming out with OpenTX, then it's like once you've learnt to use this radio, you can use the next one and the next one and the next one without having to learn each manufacturer's proprietary way of doing things. The FrSky software in here, the original version is buggy as hell. There's been updates since then, but in this version I can't even turn the volume down, because although I can turn it down when I repower the system up again, it's forgotten and it goes to full volume and it wakes the neighbours in the middle of the night if I'm playing around. So that's pretty much it from the outside. Of course, there is a little jack in here. I think that's for headphones or something. I don't know. It has a vibrator in there to alert you when there's something going on and you need to look at the screen. The screen does actually work quite well in full sunlight. It's quite surprising. I've never been a fan of colour LCDs. I believe that what I want is high contrast, so I can see at a glimpse what's going on. Now, this does work better than any other colour LCD I've seen on the market. I still don't know that there's benefits to having colour. I think it's just a bit of fluff. It's a bit of frivol. I'm happy with a really high contrast monochrome screen. There's nothing on there that can't be represented in monochrome better, in so much as it's going to be more visible in the daylight sun, which is really important. So there you go. Without further ado, let's, I should also mention it's got a charging jack. Where are we? Charging jack in there, barrel connector for charging the battery, and we'll get onto that in a moment when I pull the back off it. But that's from the outside, and I've already done a video which I explained most of this before, but I'm just going over it again. Oh, nice rubber grips for your hands. Does feel quite nice there. I was concerned that this is a big radio, I wouldn't like it physically, but I can move the sticks to all the corners. That's great, and the weight is quite strong, but I work out. I'm buff. I can hold it. I don't need this naffy neck strap thing. So that, from that respect, I mean, you know, that's the outside, but the real test of whether you might want to buy these probably lies inside. So let's rip the back off the damn thing, have a look and see. Right, getting into the Horus is pretty straightforward. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 screws. That's quite a few. That's quite a few screws, and that's important because I'll get onto why that's important in a moment. But they're just normal Phillips head screws. Now, 4 of them, these 4, are screw into metal inserts in the transmitter, which is good because metal inserts don't wear out. So you can take these in and out as many times as you like, and you're not going to have an issue. Now I need to have a little container to hold these screws. Always have a container because otherwise you'll lose them or they'll roll around on the bench and scratch the front of the radio. And I'm going to get this undone. Here we go. So I'll put these in this little plastic container so we know where they've ended up. All right, and now for your amusement, we will simply fast forward through this piece because it's boring as bat poo. And of course we have these screws here. These are different. These screw into plastic posts, which is not quite so good because where screws go into plastic posts, they tend to wear out. The plastic just gets worn away if you take the back off or if you use them too many times. So I'm not that impressed with that, but I mean, you expect that on a cheap budget radio, but on a high-end radio, I'd be looking to have metal posts in all these positions so that, you know, surely you shouldn't have to take the back off very often, but it's still just a sign of quality that screws go into metal posts. You don't end up with the problems that plastic posts produce. Right, now these aren't magnetic for some reason, didn't you? These must be brass, chrome-plated brass, so I have to tip this over and let all the screws fall out, and I'll try not to lose too many. And so, here we go. And so you don't want to leave these on the bench because they will scratch the radio when you don't want it. And there's another one. And one more. Come on, there we go. Right, so that's all the screws out of the way, which means that now we can just lift this back off, hopefully, if it's a good fit. And here it comes. It's not here we go. You don't have to take the rubber side panels off. Some radios you do have to take those rubber panels off. You don't on this one. And once we get in here, I'll just unclip a few things because there are some leads which get in the way. These little rubber feet also come off, so you need to be aware of that. I don't expect you'll be pulling yours apart, but just in case you are, this is a little bit of a guided tour of how to do it. There's some little leads in here which have to pull off the circuit board, and another one that comes off here, and one out of there, and we're done. So I'm going to look at the back of the radio first, because there is some goodness in the back here. Let's take a look at what's there. Okay, first thing to notice, we've got a couple of pots here for the sliders. They look like pretty good quality pots. I don't really care about that. They look really nice. We've got a nice wiring loom. This heat shrink on there where it joins onto the pot. So typical FrSky quality. Now the quality is really good, I'm happy with that. Now down here we have a little motor with an offset weight. I'll take that out so you can have a look. This is the vibration thing that alerts you to the fact that something needs your attention. It may be a alarm on your telemetry, it may be something else. So this will give you a little bit of a buzz. Woohoo! Nice to have a radio that's got a buzz built into it. And that's the little motor. As you can see, there is a motor and there's a little offset weight on the end here which spins around and just shakes the crap out of everything when it needs to. So there you go. Again, this is just held in with some simple screws, and it's got that connector that goes off to the motherboard, so that's kind of nice. I've got no complaints about that. And there's your module bay. There's nothing actually in there. I've actually disconnected a little connector for the external antenna because that gets in the way, but there we go. Put that back together. And interestingly, up here, this is our GPS receiver. Remember I mentioned that it was under this little cover here. Well, there's our GPS receiver. Nothing flash, pretty budget brand. Gururi, yeah, oh, I don't know. Anyway, that's it. You can see it. You can buy them on Banggood. It's it's just a little budget GPS receiver. It's just clipped in there. And as I say, the you know, it's going to be shielded by what's on the other half of this radio, which is the bit we're going to look at now. So let's get rid of the back, and here is the goodness inside, the wonderful electronic goodness inside a Horus. Let's take this other rubber foot out because we don't want that getting in the way. Let's take a bit of a tour, see what we've got here. Well, we've got a great big hulking fat battery here, and this is a nickel metal hydride battery. Comes out pretty easily. There it is. And it says it is a 2000 milliampere hour, 9.6 volts. Why 9.6 volts? I mean, as I've said so many times before, all the goodness in here runs on 3.3 or maybe 5 volts, depending on which part we're looking at. So why would you have a battery that has 3 times the voltage you need? It doesn't make much sense because you're going to have to regulate it down. Well, I think the reason they've gone this way is because look how thin that battery is. It's quite thin. It's just some AA cells, and they've made them very thin, so it'll fit in here nicely without taking up too much thickness. So it's going to keep the radio relatively thin. So it doesn't matter if actually that it's 9.6 volts, because inside here, as you'll see, there's some regulators which drop it down, and they are what we call a buck regulator. They're switched mode regulators. They're very efficient, so we're not going to be wasting any of the, or very much of the power of this battery in heat. So 9.6, that's just fine, not a problem. Nickel metal hydride, not so impressed with it. It's been my experience over the years that these nickel metal hydride batteries, you get a couple of years out of them, and then you've got to replace them. They're toast. Also, they don't really like fast charging, especially the low self-discharge units. They don't like being charged at much more than, you know, half a C is good, 1 C pushing it. You're not going to charge these at 5 C if you're really in a hurry to go flying. And down here, we have a little board. And this is one of the things I've noticed with the Tyrannus. There's lots of little boards in this thing. It's not just like the Turnigy 9X or the FrSky 9X, which I really liked because it was an incredibly elegant radio. Everything was basically on one board, nice and simple, super easy, and that made the design elegant. It made the assembly simple, and it kept the costs really low. Every time you have another little board, you've got a tool up for that board, and you've got a tool up for this board, and you've got a tool up for whatever boards you've got in here. So that puts the cost up a bit. I mean, we've even got a little board here for mounting this little connector on it. The only purpose of that board is to hold this plug, but that board has to be designed, has to be spun up, has to be manufactured, has to be installed. Everything adds to the cost. So this is not a cheap radio to make. And of course, let's do a little board count, shall we? So far, we've got that board. We've got the board that board sits on, which has got your SD card and everything. So it's 1, 2, 3. The main logic board, 4. There's a little board down here for the Bluetooth, 5. What have we got? There's another board. Oh, when we get into the other things, there's 6 or 7 boards making up this radio. And of course, that's, you know, 6 or 7 individual projects that have to be maintained and managed by the people who design and build the radio. But nevertheless, that's just one aspect that, you know, it would have been nice to simplify. One benefit of having lots of little boards is being modular, you can modify something without respinning the whole damn thing. And that's important because, as I said, this is a nickel metal hydride battery and they have their downsides. And this is a nickel metal hydride battery charger, and it's built into the transmitter. So if you want to replace this NIMH battery with a LiPo, all FrSky has to do is make a new one of these that has a balanced LiPo charger on it. Woohoo! And then you can charge your LiPos through this barrel connector from a plug pack. That would work really nicely. Will they do it? I certainly hope they do, because I'm not a fan of nickel metal hydride batteries. And But by being modular, they can do that without having to respin the whole board. That's kind of good. Now I've removed the 4 screws that hold in this sub-assembly, and that'll enable me just to hinge this out of the way. Take out this little connector here from the battery charging circuit, and this will hinge out of the way. There's a little cable here. It's all quite nicely designed. So now we've got access to our main logic board. And oh look, lo and behold, there's another subboard. So that adds to the count again. This is the RF board. Let's take a little bit of a closer look at that. Now this is FrSky's usual high quality. There's not much to see there. Incredibly small components, fantastically small components on this little subboard. We've got 3 UFL connectors. One goes off to the built-in 2.4 gig antenna. One goes off to the external antenna, and one isn't used on this one. Now, as I say, this is a beta test version, so what you see here may not be exactly the same as what you would buy if you go out and buy a Horus in the store now. So we're not looking at so much in the detail as the general overview of the way it's been laid out and so forth. But the manufacturing of this, that's just fine and dandy. I'm happy with the quality and that, all very good. The chipset is the same one they've been using all the way along, basically, same protocol, so it's the ACCST or whatever it is. It's proven, well proven in the field, a fantastically resilient protocol, so no qualms about that whatsoever. As I say, the manufacturing of this board, it seems just fine and dandy, got no grizzles about that. Yeah, what's to say? That's great, looks excellent. Right, now here's the brains of the whole thing. This is the main processor on the logic board. It's an ARM, it's an F4, which means it has a built-in hardware floating point math processor, which is, means it can do sums real quick, and that's fantastic. It's got plenty of grunt. And the one thing I'm really, really pleased about is that it is in a quad flat pack. What does that mean? Well, you can see along here the very, very fine wires, and they all solder to the connectors along the edge. That is great, because one of the other ways of packaging these processor chips is in a thing called a BGA, or a ball grid array package, and they're nowhere near as reliable as these quad flat packs. What happens with the ball grid array is all the little connectors are underneath, all the little solder joints are underneath. There's no wires coming out the side. And that means that if there is, what tends to happen is if there's changes in temperature, physical stress, sometimes those little solder connections can break or become intermittent. Anyone with an Xbox knows about reflowing the BGAs. Well, not anyone, but a lot of people know about reflowing BGAs because over time they can become intermittent and cause problems. This is a quad flat pack, excellent choice. It's going to be robust and reliable. Even though it turns out to be a much bigger piece of silicon, it's still, on a board like this, that doesn't matter. You've got plenty of room, so they've taken the right choice in doing that. Yeah, it's a really capable processor. It's the most powerful processor you're likely to see in a transmitter of this type. You've got ARM processors in your smartphones as well, but they're an A series processor, which aren't really designed for the kind of low-level stuff that the STM series, or this one, which includes the F4. So yeah, good choice of processor, no worries there. Let's move along a bit, because over here we've got the power supply circuitry, and remember I mentioned that this whole thing runs on 9.6 volts. Get this little wire out of the way. Runs on 9.6 volts, but these processors only need about 3 volts to run. So we've got a couple of switch mode regulators down here. You can tell these little inductors here, they do the switch mode regulating. They bring it down. So we've got a couple of what we call rails, which are the voltages that the circuitry will use. Interestingly, there's an unpopulated chip in here. I don't know what that's for, but it's not uncommon, certainly in beta stuff, to see unpopulated areas like this, because they think, well, we might have to add that later, or this could be a new feature or something. So they left that out. It does seem to have some here. That's probably a microcontroller, because these could be ICSP. These are perhaps programming pins designed to go to that controller and allow you to adjust various, reprogram it basically. So this could have been for smart stuff. I don't know what they do, but don't care. It's not actually in there, so we won't dwell on it too much. Now over the other side, you're going to have to turn around a bit. There's another board that I mentioned before, and I think this is Bluetooth. I haven't actually checked the part numbers and everything, but a little board here which will give you Bluetooth connectivity, perhaps because it has an antenna wire which wanders way up here, as you see where I'm moving this around. And in there, as you can see underneath, if I move this out of the way, you can see the little PC board antenna. Looks like a Bluetooth PC board antenna under there, tucked out of the way. So yeah, that's nice and simple. What else is to see on this board? Let me have a quick look and tell you. Okay, I'm up to 7 on the board count now, the number of boards that are involved in this. And here's another little board up here. I don't know what this is. I haven't been able to read the little writings. Probably can when I get home. If I can, I'll leave a little message along the bottom of the screen here. But it's another little board. Now, chances are that FrSky don't make this board or the Bluetooth board. They just buy them in and just glue them, solder them to the board. It's so much easier than having to design that circuitry yourself. It's a building block board. It's quite common to do this with, especially early prototype stuff and even production stuff, because it's just so much cheaper to buy these, probably 50 cents. And whereas if you have to design it yourself, recovering the cost of all that effort becomes very difficult. So it's a very common thing to do. And I say, I don't know what this one's doing. It's not immediately obvious by its position or anything like that. It may be related to the GPS perhaps, because there's the GPS connector there. I don't know. I'm not going to pretend I do. So simple. Now, the other big feature, of course, of these Tyranni, not a Tyrannus, it's a Horus. God, the other big feature of the Horus is the stick units. And here they are. Now, one thing you'll notice immediately is there are no pots. There are no pots in these stick units. Why is that? Well, because down in here, there is a little Hall effect sensor, a little magnetic sensor. And on the end of, see that little silvery bit there? That is a magnet. So, in effect, what we have here is a compass with a magnet over it. And when we move the stick like this, the magnet rotates, and this little compass device here picks up the magnetic heading from that magnet. So it's really kind of simple, and there are there's no sliding parts apart from the bearings and things. There's nothing to provide drag, nothing to make the sticks feel sticky. I suppose sticks should feel sticky, shouldn't they? Oh, well, never mind. But yeah, it means that the sticks can be very, very light without drag. And also, the mechanism is actually surprisingly simple, isn't it? I mean, there's not a lot in these stick units. So yeah, quite cool. One thing that I don't really like about Hall effect stick units is there's no damping. What does that mean? Well, you watch. I'll release and let that stick go. Look how that bounces. So the sticks bounce like that because there's very little friction. There's nothing to stop that oscillation. So the springs bounce backwards and forwards. Now, one nice thing about sticks with pots in them is the pots usually have a bit of grease on the shaft, and that provides like a rebound damping. So sticks with nice pots don't make that noise. So I guess it's just a personal thing. It doesn't hurt to do that. But yeah, just an observation. Now, yeah, these stick units is why not have Hall effect? I mean, they're going to last forever. Unless the magnet loses its magnetism, which is unlikely with neodymium magnets, or the compass unit there, the Hall effect sensor stops working, then this is just going to work forever. The little bits of, and even see on this piece here, they've got a sort of a nylon surface on the little arm there, so that where the pins touch, it's not going to wear out. It's not metal to metal. It's a low friction plastic, a nylon or a Delron or something like that. So this will last forever, maybe even longer than forever. Maybe when the universe is finally over, all that will be left are the stick units out of Horuses. Who knows? Be worth waiting around to see, I suppose. So there you go. That's the guts inside. Now, just looking at things like the switches, you'll see that they have heat shrink. And so this is a pre-production prototype. So the fact they've even put heat shrink on here bodes well for the manufacturing. But what you can also see here is one of these plastic posts where the screws go in. And you can see why they wear out if you're going to have to do a lot of that sort of screw in and out. There's the brass ones, the metal ones. They'll last for almost forever. And again, let me go back to talking about why you might want to take the back off and on this thing a lot. Now, I mentioned I'm not a fan of nickel metal hydride batteries. That's what it comes with. I don't know why. I really honestly don't know. Maybe it's for shipping. Maybe because they can ship these things with a battery in them, but they can't ship them with a lithium battery in them. Although you can ship mobile phones, so that's probably not the reason. The problem is that if you just want to throw a LiPo in there of some shape or flavour, you're going to have to take the back off every time you want to charge it. And sure, the LiPo may last for a month or two at a time, but over a period of time, you're going to wear out those screw posts, and it's going to be so damn inconvenient to have to take the back off because this is an NIMH charger. So you're going to have to take the battery out, put it on your four-button charger, charge it up, put it back in, screw the back on. What a lot of faffing around. Unless FrSky or some third party makes a LiPo charger board to replace the NIMH one, then you're buggered. So this was a really bad choice, in my humble opinion, for FrSky to use a NIMH battery. This is 1990s technology, not 2017 technology. So yeah, a bit of a shame. Now, I'm pretty sure that we'll see, if this transmitter gets any sort of popularity, we'll see LiPo boards coming out for them. So that's a temporary thing, but it would be certainly a major annoyance if I was going to use this. But I'm not going to use this radio for two reasons. Firstly, this is the beta test version that they sent out, and there have been some changes to the circuitry, I gather, since I got this. FrSky haven't responded to my emails in respect to what those changes are or how I get my hands on them. So I'm not going to fly a beta test radio because I understand there were some issues. Oh, one thing I meant to point out before I go on. This is the LCD display board. Now behind here, there is a metal plate. You can probably get a glimpse of it just down here. Can you see the silvery metal plate in there? It's an aluminium backing on the LCD. That's what will block the GPS transmitter. Well, not necessarily block it, but it will reduce its ability to function properly. You know, it'll be harder to get satellite locks. Up in here, right up in here, you can probably see there is the 2.4 gig transmitter antenna. This is for your RC link. And it's right up in there. It's quite small, and it's just only facing, it's horizontally polarized for a start, which is not always a good look because a lot of the antennas will be vertically polarized. The problem with horizontal polarization is when you're looking from this end, there's nothing there. When you're looking from that end, there's nothing there. So if you're flying your model out sideways while you're holding your transmitter, you get to the far away on the side and you might be running a bit low on radio frequency strength. And also there's only one of them. Now a lot of the other radios I've looked at, like the Futaba and others, and I think even the FrSky have two antennas. One's vertical, one's horizontal. They're at 90 degrees to each other, just like your receiver antennas. But this only has one. Hopefully, and remember I mentioned on that little RF board there is an unused UFL connector. Hopefully in the new ones, they've put another antenna in there at 90 degrees and connected it up, and they're using transmitter diversity. And the way that usually works is it'll send one packet of data using one antenna and the next packet using the antenna at 90 degrees. So regardless of the orientation of the receiver, at least one of those packets is always going to be aligned with the antennas on the model, and therefore you'll get through even at the limits of range. So, but they haven't done it here. So I'd be a little bit skeptical about the area of coverage that this little antenna provides. And also, the other thing is you can still see, if I look in here, if you look through here, there's a little, see that metal down there? That's the backing plate on the LCD. So this is like, well, uber close to a big metal plate. You don't put an aerial that close to a big metal plate. It's going to distort the radiation pattern and detune the antenna. So this is probably what I think is perhaps the worst feature of the radio from a technical perspective, is this antenna and its placement and the use of only one. It's too close to this large metal plate on the back of the LCD, and it only gives you horizontal polarization. I'm not impressed with that. I think that's a bad choice. But hey, maybe I've got it wrong. Maybe FrSky have come up with some super cool black magic for antennas that enable it to work really well. But I would be very worried about getting good, consistent, reliable range with the setup in this beta radio. Hopefully it's better in the productions, but I don't know because they don't tell me. There you go. What more can I say? Not a lot to say really. That's it. That is the Horus radio. And I probably said Tyrannus when I meant Horus several times in this video, but I'll only notice it when I'm editing and I shall kick myself. But I'm not going to do it again because I've already filmed this twice. First time my audio failed and I didn't realise it, so I was yabbing away and the batteries had gone flat in my wireless microphone. So I spent a whole day for no purpose. But that's what happens sometimes. That's one of the frustrations of running a video channel like this. So there you go, that's it. Now if you've got comments, if you've got questions, anything to ask, anything to say, put me right if I've made a mistake, then please do so in the comments section below this video and I'll be more than happy to read them, appreciate them, and if necessary, reply to them. And so, in the meantime, I shall put this back together. Thank you for watching and get back to the bench. Bye for now.